The history of military aviation is often written in clean lines and fresh sheet designs, the sweeping delta of a Mirage, the alien angles of a stealth fighter, or the brutalist efficiency of a new interceptor. But occasionally, the most significant shifts in air power don't arrive in a factory-fresh box. Sometimes they arrive in the form of a Frankenstein's monster, a machine that has had its heart and brain ripped out and replaced with silicon and fury, all while wearing the same battered skin as its ancestors. If you look at the flight line of the People's Liberation Army Air Force today, past the media darling J-20S, you will see a fleet of heavy fighters that look confusingly familiar, yet fundamentally wrong. They carry the classic predatory silhouette of the Soviet Sukhoi flanker, the arched spine, the underslung intakes, the massive wingspan. But the nose cone, traditionally black on Chinese flankers, is a stark, blinding white. And protruding from that modern white radome is a relic that shouldn't be there, a pitot tube. This visual anomaly is the Shenyang J-11BG, and it represents something far more dangerous than a new airframe. It represents industrial maturity. For decades, observers dismissed Chinese aviation as a game of copying and pasting, a desperate attempt to reverse engineer Soviet Cold War iron. The J-11BG shatters that assumption not by being new, but by being old. It is a midlife update that takes the venerable J-11B, a localized version of the Su-27 that was once plagued by reliability issues, and injects it with the kind of avionics and weaponry that keeps U.S. Navy planners awake at night. It is the realization of a terrifying doctrine. You don't need a fleet composed entirely of stealth fighters if your older jets can see just as far, shoot just as long, and fly just as hard as the cutting edge. The J-11BG is the ultimate missile truck, a heavyweight brawler designed to loiter behind the stealthy tip of the spear and unleash hell from standoff ranges. To understand the J-11BG is to understand the ruthless pragmatism of Chinese military planning. It signals a shift from the obsession with acquiring new platforms to the mastery of maximizing existing ones. This isn't just about painting a radome white. It's about solving the physics of radar interference with software. It's about finally curing the heart disease of indigenous engine production. And it's about accepting that a good enough upgraded fighter available in the hundreds is infinitely more valuable than a perfect prototype that never leaves the hangar. The J-11BG is what happens when a rising superpower stops trying to impress the world with airshow concepts and starts preparing for the grind of a high-intensity conflict in the Pacific. If deep dives into the strategic and technical decisions behind modern fighters interest you, subscribe. There are plenty more aircraft worth examining closely. The story of the J-11BG begins with the J-11B, an aircraft that was, for a long time, the problem child of the PLAAF. When Shenyang Aircraft Corporation first localized the Su-27SK production, the result was a formidable airframe let down by teething issues. The J-11B was supposed to be the indigenous assertion of independence, replacing Russian avionics with Chinese equivalents, and crucially, replacing the Russian AL-31F engines with the domestic WS-10 Taihang. It was a rocky road. Early WS-10S were notorious for their poor reliability, with mean times between failures that grounded entire regiments. The radar, the Type 1493 pulse Doppler, was capable but essentially a 1990s solution to a 21st century problem. By the mid-2010s, the PLAAF faced a dilemma. They had a large fleet of J-11BS that were aerodynamically sound and structurally young, but electronically obsolete. In the era of stealth and electronic warfare, a mechanical scanning radar is like bringing a flashlight to a laser fight. You might see what's in front of you, but everyone else can see you from miles away. Shenyang's initial answer was the J-11D. This was the superflanker approach, a complete structural redesign using more composites, canted radar bulkheads, and a new fly-by-wire system, essentially creating a Chinese analog to the Russian Su-35S. But the J-11D suffered from the classic curse of military procurement. It was too expensive and arrived too late. With the J-16 multi-role fighter already entering service and the J-20 stealth fighter ramping up production, the PLAAF didn't need another expensive new airframe type. They needed a way to make their existing hundreds of J-11BS relevant again. The J-11D program was canceled, but its brain, the advanced avionics, the radar technology, and the fire control systems, was salvaged and transplanted into the existing J-11B fleet. The result was the J-11BG. The most controversial and technically fascinating aspect of this upgrade is the radar. The shift from the black radome of the J-11B to the white or light gray radome of the BG is not a cosmetic choice. It is a necessity of physics. The old black radomes were optimized for the specific X-band frequencies of the mechanical Type 1493 radar. The new white radomes use a broadband wave-transmitting composite material, essential for the frequency agility of an active electronically scanned array, or AESA, radar. The presence of an AESA radar on the J-11BG is a game-changer. Unlike a mechanical radar, which must physically turn a dish to scan the sky, an AESA system uses hundreds of tiny transmit-receive modules that can steer the radar beam electronically in milliseconds. This allows the J-11BG to track multiple targets while simultaneously scanning for new ones, map the ground, and even perform electronic warfare attacks, all without the lag of a mechanical gimbal. However, eagle-eyed enthusiasts noticed a glaring detail. The J-11BG retains the nose-mounted pitot tube. In the world of AESA radars, a pitot tube on the nose is usually considered a heresy. A metal tube sitting right in front of a radar emitter creates a blockage, scattering the beam and creating a blind spot, or ghost returns. Most AESA-equipped fighters, like the F-22 or J-20, move the pitot sensors to the side of the fuselage to keep the nose clean. The fact that the J-11BG kept the tube led many to speculate that it wasn't a true AESA, or perhaps a cheaper passive AESA or PISA. But this underestimates the software engineering involved. Much like the upgrade program for the Taiwanese F-16V, which also fits an APG-83 AESA radar behind a nose with a pitot tube, the Chinese engineers likely utilized digital beamforming algorithms to compensate for the obstruction. The radar's computer knows the pitot tube is there and subtracts its interference from the return signal, essentially editing it out of the picture in real time. This decision to keep the tube saved the PLAAF the immense cost and time of requalifying the entire flight control system's air data inputs. It's an ugly engineering solution, but it works, and it allowed the upgrade to be rolled out rapidly across the fleet. While the specific model of the radar remains classified, open-source intelligence and export parallels suggest it is likely the JKL-24, or a derivative of the Type 1475 family. This system is believed to use gallium nitride, or GaN technology, a semiconductor material where China holds a dominant position in the global supply chain. GaN modules can handle higher power densities than older gallium arsenide modules, meaning the J-11BG can pump more energy into the sky, achieving greater detection ranges and stronger burn-through capabilities against enemy jamming. We are talking about the ability to detect fighter-sized targets at ranges exceeding 200 kilometers and high-value assets like tankers or AWACS at nearly double that. This radar transforms the J-11 from a short-sighted boxer into a sniper. But a sniper is useless without a rifle, and this brings us to the primary strategic rationale for the J-11BG's existence, the PL-15 missile. The legacy J-11B was limited to the PL-12, a decent active radar missile roughly comparable to the early AIM-120 AMRAAM. The J-11BG, however, is fully integrated with the PL-15. This missile is a monster of modern air combat. Utilizing a dual-pulse rocket motor, the PL-15 has an engagement range estimated between 200 and 300 kilometers. It features its own miniature AESA seeker, making it incredibly difficult to jam in the terminal phase. The combination of the J-11BG's powerful nose radar and the PL-15 creates a massive no-escape zone for enemy aircraft. The J-11BG can launch from high altitude and high speed thanks to the flanker's kinematic performance, lobbing missiles at targets that might not even know they are being tracked. The visual confirmation of this capability is subtle but distinct. If you look at the wingtips of a J-11BG, you will see that the missile launch rails have changed. The old J-11B used a stepped pylon designed for the PL-8, a derivative of the Israeli Python III, characterized by its large stabilizing fins. The J-11BG features a streamlined, straight rail. This is designed for the PL-10, China's latest short-range infrared missile. The PL-10 is an imaging infrared missile with thrust vectoring controls capable of engaging targets at 90 degrees off boresight. In a dogfight, a J-11BG pilot doesn't need to point the nose at the enemy. They simply need to look at them through their helmet-mounted display and pull the trigger. The missile does the rest, pulling up to 60 G-turns to intercept. The switch from the PL-8/PL-12 combination to the PL-10/PL-15 combination essentially skips a generation of air combat capability, bringing the 1990s airframe into parity with the latest Western 4.5 generation fighters. Under the skin, the transformation is just as profound. The cockpit, while not the single-piece panoramic touchscreen of the J-20, has been heavily digitized. The old steam gauges and early generation MFDS of the J-11B have likely been replaced by larger high-resolution screens and a new mission computer capable of sensor fusion. In the old J-11B, the pilot had to mentally stitch together the picture from the radar, the data link, and the radar warning receiver. In the J-11BG, the computer does the heavy lifting, presenting a unified tactical picture. This is critical because the J-11BG is designed to operate in a network. Through high-speed data links, it can receive targeting data from a forward-deployed J-20. The stealthy J-20 penetrates the enemy air defense network, running silent, and relays the coordinates to the J-11BG, loitering safely back. The J-11BG then unleashes its PL-15S, acting as a remote magazine for the stealth fighter. This tactic maximizes the strengths of both platforms, the J-20's survivability and the J-11BG's massive payload capacity. Powering this beast is the Shenyang WS-10B Taihang engine. If the radar is the brain and the missiles are the fists, the WS-10B is the healthy heart the flanker always needed. The original WS-10A was a source of constant anxiety for PLA pilots, prone to compressor stalls and requiring frequent overhauls. The WS-10B, sometimes referred to as the Series 3, is a mature, reliable power plant delivering around 132 to 144 kilonewtons of thrust in afterburner. This increase in thrust is vital because the J-11BG has gained weight. The new avionics, cooling systems for the AESA radar, and the structural reinforcements required to carry heavier payloads have pushed the maximum takeoff weight up to nearly 33,000 kilograms. The WS-10B ensures that the J-11BG retains the legendary flanker agility, maintaining a thrust-to-weight ratio that allows it to sustain energy in a turn and accelerate vertically in a way that few Western fighters can match. The engine nozzles, often seen with a silver or metallic finish on the B model, are now typically darker and feature composite petals on the BG, a sign of better thermal management and material science. The operational reality of the J-11BG is already being felt in the Pacific. These aircraft are not hangar queens. They are the workhorses of the PLAAF's Eastern and Southern Theater Commands. We have seen them deployed to Woody Island in the South China Sea, conducting intercepts of U.S. Navy P-8 Poseidons and RC-135 rivet joints. In one notable incident, a J-11B, likely an upgraded variant, flew aggressively close to a U.S. surveillance aircraft, a maneuver that requires immense confidence in both the airframe and the engine's response times. The J-11BG's long range, thanks to the massive internal fuel volume of the flanker design, allows it to conduct combat air patrols that last for hours without needing tanker support. This is a crucial advantage in the tyranny of distance that defines the Pacific theater. While a lighter fighter like the J-10C might need to refuel to reach the Spratly Islands, the J-11BG can fly there, patrol, fight, and fly back with fuel to spare. In exercises like Eagle Strike with the Royal Thai Air Force, the J-11 series has historically had a mixed record. Early engagements saw J-11S struggling against Thai Gripens in beyond visual range, or BVR, scenarios, falling victim to the Gripen's superior avionics and AIM-120 missiles, while dominating in close-range dogfights. However, reports from the 2023 iteration of the exercise suggest a shift. The J-11BGS, now equipped with AESA radars and simulated PL-15 capabilities, were able to hold their own or dominate the BVR engagement envelopes. The tables have turned. The Chinese flanker is no longer just a kinematic brute. It is now a smart shooter. The integration of the KL-700B electronic warfare pods further enhances this survivability. These pods, mounted on the wing stations, allow the J-11BG to perform escort jamming, blinding enemy acquisition radars, and creating a corridor for strike aircraft. It transforms the fighter into a dual-threat platform, capable of hunting aircraft and suppressing air defenses simultaneously. Given its combat record and the costs involved, was the cancellation of the J-11D in favor of this upgrade justified? Or should they have pushed for the super flanker airframe? Let me know in the comments. When we compare the J-11BG to its global peers, the picture becomes even more interesting. The most obvious comparison is with the Russian Su-35S. On paper, the Su-35S is the ultimate flanker, with thrust vectoring engines and incredible maneuverability. But electronically, the J-11BG has likely surpassed its Russian cousin. The Su-35S relies on the Urbis-E AESA radar. While powerful, it lacks the LPI, or low probability of intercept, characteristics and jamming resistance of the J-11BG's AESA. Furthermore, the Russian R-77-1 missile lags behind the PL-15 in range and seeker technology. It is a supreme irony that China, which spent decades learning from Russia, has produced a flanker variant that is arguably superior in modern air combat metrics to the best Moscow can offer. The Su-35S might win an air show with its Cobra maneuvers, but in a silent electronic BVR duel, the J-11BG's superior eyes and reach give it the edge. Against the American F-15EX Eagle II, the comparison is tighter. The F-15EX features the APG-82 version 1, widely considered one of the best radars in the world, and the EPAWSS electronic warfare suite, which is likely superior to the J-11BG's indigenous systems. The F-15EX is also a missile truck, capable of carrying an absurd number of AMR AAMS. However, the J-11BG is available in numbers right now. The PLAAF has hundreds of J-11BS ripe for this conversion. It provides a good enough counter to the F-15EX, capable of trading shots at equal or greater ranges. The J-11BG doesn't need to be better than an F-15EX one-on-one. It just needs to be dangerous enough to force the F-15EX to go defensive, disrupting its mission. Against the regional threat of the Indian Rafale, the J-11BG offers a contrast in philosophies. The Rafale is a masterpiece of sensor fusion and electronic warfare with its Spectra suite, and it has a much smaller radar cross-section. In a complex environment, the Rafale's ability to hide and jam gives it a distinct advantage. However, the J-11BG brings brute force to the table: a massive radar aperture, higher service ceiling, and higher speed. In the thin air of the Himalayas, where the J-11BG is deployed with the Western Theater Command, the sheer power of the WS-10B engines and the large wing area of the flanker give it a performance edge over smaller deltas. The J-11BG can fly higher and shoot further, attempting to negate the Rafale's finesse with raw energy and reach. One of the less discussed but vital aspects of the J-11BG program is what it says about China's industrial supply chain. Upgrading hundreds of fighters with AESA radars requires a massive, steady supply of gallium nitride TR modules. The scale of this retrofit program confirms that China has fully industrialized the production of advanced military semiconductors. It is not building boutique batches of high-tech gear. It is rolling them out like consumer electronics. This industrial depth is a strategic asset in itself. In a prolonged conflict, the ability to replace and repair advanced avionics is just as important as the performance of the avionics themselves. The cockpit ergonomics of the J-11BG, while an improvement, likely still lag behind the latest Western standards. The J-20 and J-10C have moved to massive single-panel wide-area displays, or WADS, that function like giant iPads, allowing for complete customization of the data feed. The J-11BG, constrained by the physical dimensions of the legacy J-11B instrument panel, likely retains a layout with multiple smaller MFDS. This implies a higher cognitive load for the pilot compared to a J-20 or F-35 pilot. The J-11BG pilot is still managing a fourth-generation cockpit interface, even if the data feeding it is fifth-generation quality. It's a compromise, trading ergonomic perfection for speed of upgrade and cost reduction. Maintenance crews have also had to adapt. The AESA radar generates significantly more heat than the old Doppler set, requiring upgraded liquid cooling systems. The white radome itself requires more care to ensure its wave-transmitting properties aren't compromised by scratches or poor paint repairs. The WS-10B engines, while reliable, are FADEC controlled, or Full Authority Digital Engine Control, meaning the ground crews are now diagnosing software glitches as often as mechanical ones. The J-11BG is a more complex beast to keep in the air, but the PLAAF's ground crews have matured alongside the aircraft. The days of relying on Russian technicians to fix deep-level issues are gone. The J-11BG is supported by a 100% domestic logistics chain. The naval variant, the J-11BGH, deserves a special mention. Assigned to the PLANAF, or naval aviation, these land-based fighters play a critical role in anti-access/area denial, or A2AD. They are compatible with the YJ-83K anti-ship missile and likely the YJ-91 anti-radiation missile. A flight of J-11BGHS can saturate a carrier strike group's defenses with subsonic sea skimmers while simultaneously threatening the carrier's air wing with PL-15S. They are the guardians of the 9-dash line, using their range to enforce China's territorial claims far from the mainland. The upgrade ensures that these naval flankers remain relevant, even as the U.S. Navy introduces the F-35C and upgraded Super Hornets. Ultimately, the Shenyang J-11BG is a testament to the idea that quantity has a quality all its own, especially when that quantity is upgraded to modern standards. It is not a stealth fighter. It will light up enemy radars like a Christmas tree. But it is designed to operate in a world where stealth is not the only variable. By pairing with the J-20, utilizing long-range missiles, and leveraging a powerful AESA radar, the J-11BG remains a lethal predator. It bridges the gap between the past and the future of the PLAAF, proving that you don't always need to build a new plane to change the balance of power. Sometimes, you just need to give an old brawler a new pair of eyes and a longer reach. The white radome of the J-11BG is a warning. The flanker is far from dead. It has simply evolved. The legacy of the J-11BG will likely be that of the great stabilizer for the PLAAF. It allowed the force to transition to a high-tech footing without the dangerous dip in readiness that usually accompanies a generational shift. Instead of retiring the J-11BS and waiting for J-20S to come off the line, China upgraded them, keeping the numbers high and the capability relevant. It is a lesson in fleet management that many Western air forces, currently shrinking as they wait for expensive new platforms, might view with a degree of envy. The J-11BG may not be the poster child of the Chinese Air Force, but in a conflict tomorrow, it would likely be the one doing the heavy lifting, firing the missiles that matter, and holding the line while the stealth jets do the surgical work. If you found this analysis useful, a like helps more people discover these deep dives. Thanks for watching.